I want to do apologies for that. Wasn't sure what's going on. Yes, thank you very much. Oh my God. I don't know where the audio cut off, but then let's just quickly go back. I haven't gone really far. So let me just go back to where we get to talk about the Open Graph protocol. Okay. All right. Okay, let me just start from the beginning, basically. So what I was saying is in this session, we'll cover a few things. The first one, we'll talk about the Open Graph protocol. The second one, we'll talk about frames. And then we'll also talk about, starter kit and tools for building frames. And then we talk about Axelar GMP, how you can, create custom functionality to interact with different blockchain, leveraging Axelar General Message Passing, GMP for short. And then we'll go into the demo session. Right. So I in the recent term, like in the recent times, we've seen like the last few years, we've seen the rise of social media usage among individuals, professionals, and various other groups. Um, which kind of tells a compelling story about how rapid evolution of these platforms are. So this phenomenon highlights how social media is increasingly leveraged to influence, connect, and transform the way we communicate and interact globally. So imagine a social media post or cast that is not just a static piece of content, but a dynamic way of interacting and also giving you that interactive experience within the social media app. I know you might be wondering, like, what exactly is why do we even need this in the first place? But then the concept here is that we've talked about web one, we've talked about web two and web three, where the first phase was everybody was just like content creator, a consumer rather, a content consumer, and the era where we get to have interaction in social media apps, and then finally the decentralized ecosystem in web three. But then what if you could have an application, a social media application that allow you to do things like making purchase, interaction, polls, and all of that within your social media app without having to leave that application that you're currently on. And on your feed, you can just do that, move on, and then keep scrolling on your timeline. This was exactly the vision for Frame, which is a way for you to embed mini application directly into posts, turning them into things like pools, games, live feeds, and even more. And the interesting part is that this inspiration came from an old technology, which is called the Open Graph Protocol, which was repurposed to fit this new decentralized world. So the journey of Frames began with a simple idea to make social interactions more engaging and interactive. So developers were given powerful tools to create this mini app I mentioned without central approval, which also give us a new way to rethink how we build social media app and embedding real world use cases into this app where users can interact directly without having to leave the app and also doing it just on their feeds. So today, Farcaster frames represent the main deal of what decentralized social media can achieve. I mentioned Open Graph protocol when referring to an old technology repurposed to fit this new decentralized ecosystem. So let's talk about Open Graph protocol. In case you're hearing this for the first time, don't worry, I'm going to do my best to explain how it started and what the example looks like. Open Graph protocol. Open Graph protocol was originally introduced by Facebook in 2010 It allows web pages to become rich objects in a social graph by defining structured metadata, right? So this was originally introduced by Facebook. By the end of the day, the idea is to allow web pages to become rich objects in a social graph by defining structured metadata. What metadata are they even talking about? So I'm going to show you in the example, but then let's just proceed. It also enables social media platforms to display enhanced preview of shared content, including titles, images, and description, improving engagement and visibility generally. So what does the example looks like? The open graph, this is an example of open graph meta tags in HTML. We have the header tag. We have, so this is an example in HTML where you have the head, and then within the head, you have like the meta tags for titles. You have meta tag for OG type, where you could specify like a file part or like an image, a video, particular content. And then we have the OG type property for a meta property for OG URL, where you could also specify the URL. Property for OG image, where you can specify an image, and then you can make a reference to that particular image. So this is how meta tags looks like in HTML. But then, how does Farcaster extend this functionality from Open Graph? So let's quickly talk about what Farcaster frames are, and then we'll now take a look at the example of a Farcaster meta tag, how it's similar to this, or how it extends the Open Graph capability to even build more robust application. So Farcaster frames. Frames are standard for creating interactive and authenticated experience on Farcaster, right? Embeddable in any Farcaster client. In this example, we'll be using Webcast as a Farcaster client, but then still, like, there are so many other examples that you could try out with, and at the end of the day, you could see, because it supports other applications like Yop, Supercast, Launchcaster, Canvas, and so on and so forth, where you could test your Farcaster frames on. So Farcaster frames became a significant feature. Farcaster frame itself, it became a significant feature by addressing the key issue in social media, leveraging this open graph technology that we just talked about, engaging developer and aligning with value within the decentralized community. So, but then let me show you what a frame example looks like in HTML. So this is you can see that there are some similarities between this and what I showed for the open graph example, where it's kind of similar, but what you can identify here is that you can see the property here has a notation of FC frame, and then for image you have FC frame image, and then we specify the image. For the property, like if you want to, the cool part is that if you also want to continue using the open graph text, you can just call that same property and it's going to work fine. Additional functionality that comes with leveraging the Farcaster approach to this is having property like FC frame button, where you could have button, and the maximum button you can have in a particular frame is 4 at a time. So you can have button, which these are things that does not exist before now. You can have input and some other functionality when you are building your frames to even enhance the way people interact with your frames and some of the things that they can do directly on your frames. Don't worry, we've seen all of these things during the demo where I would showcase how the interaction works under the hood and also how you can build your own frames. So this is a graphical representation of how this should look like. So for example, this example showcase quiz, where you could have a frame that looks like this within your timeline. And then you see button like get started. When a user clicks on this get started, it goes directly to a quiz question where the responses are dynamic. So the option here, this quiz question says, who is the greatest passer of them all? And then you have two options, full bar and full and then bar. Then the first one is full, the second one is bar. And if you click on this would redirect you to a page saying, oh, sorry, that wasn't right. And then allow you to play again. So play again, you go back to the first page where you can get started again, right? But then if you click on bar, which is the other button, it's going to tell you, yes, congrats, collect your prize on the site. And in fact, you can click and then to redirect to any place that you can claim your prize. And also, if you want to like give maybe NFT to reward whoever gets the correct answer. So it's very easy. What you just need to do is to, instead of showcasing like an open image, you can have a button that shows mint NFT, and then user will be able to mint that NFT. And you can also extend and then go to any other websites. So a typical example of how some of these frames looks like, if you are a user if you have a Farcaster account, then you might already seen all of these things. But then let's just quickly look at how the real world example looks like. So we have these where you could showcase like things like read more, and it's going to open a new page for you to read more about this particular hackathon. And also official rules, you can click here to take it to the official docs, or take it to where you can sign up. So this is one thing you can do. Another one is things like minting NFT directly. And also you can nominate a friend, and you can also view collections. This will take you out. For mint NFT, can also take you out to where you could mint NFT. But if you want the user to have the ability to mint NFT directly from this without leaving the app, you can also do that. So another one is this, which is kind of similar to the first one, where talking about speedrun Ethereum. You want to check it out, you want to start building and all of those things. And then finally, this is what the demo will be working on looks like here, where it's very simple. The landing page is very simple, and then we click things to see how things work. Don't worry, in the demo, I'll show you what the end result looks like before we start coding. So how does Farcaster frames work? We've learned about frames, we've learned about OG, the Open Graph protocol. But then Farcaster frames themselves, how does it work under the hood? This is one example I find like a very graphical representation I find very useful, where you could see like the client and also the frame server. So basically for frame developers, you need to know that frames consist of two different parts, like the frame definition, which is like the app, the client, where you tell the application what to render and where to send the action. And then we have the frame server that could help you handle action that is received from the client. You could handle it on the server, do some sort of custom logic, do all of this, your custom implementation, and then send back the data to the front end client. So as you can see in this example, where we have like frame action, it goes directly to the server, and then gives a result back to the client. So it could also go as far as having a hub or underlying technology that you also want to interact with. Maybe after user send a frame action to a frame server, you want to do some validation, you have like other things to do, you can do that interaction. Like in our case, during this example, once we get the request from the user in our server, we'll make a request to interact directly with the contract that we have on chain to send message from one protocol to the other, and then get the feedback, send it back to the client. So this is like what the whole thing looks like when you're interacting with frame from your client. So what are some of the starter kits and tools for building frames that are available today? We have a lot of them. In fact, I've seen a lot. I've seen a lot of packages. I've seen a lot of things, but I just highlighted like a few ones that you might all find very interesting. Number one is Frame.js. Is like a wrapper. Basically, all of these tools create a wrapper around meta tags, and even making it easier for you to interact with, like, to build your application fast with less code, and also calling all of this function that is already built for you. So we have Frame.js, we have a frame in 100 lines, we have the on-chain kit, we'll be using on-chain kits in this tutorial, in this workshop. We have frog.fm, it's another package that you could use, or tools or starter kit that you could use. And then I added Webcast frame validators here. This might not be a direct tool, but it's a very relevant tool that you can use to test your application before you go live. So in fact, you can text it directly before you now paste the link publicly. I'll show that once we get to the demo in a second, where we'll be using it to test our application that we already deployed. And then we have Nina. Nina also help with, it's a infrastructure and tool for frame servers generally. It provides resources for managing the backend aspect of your frames. So these are some tools that are available, and I think we have awesome frames repository also that include like all of these tools that you can check out on your own. So now that's it about frames. Now let's talk about Axelar GMP, because this tutorial is focused on not just how you can interact on chain, but how you can interact multi-chains. So, and in this tutorial, I want to focus on using the Axelar general message passing. First, Axelar general message passing, we have two functionality available to you as a developer, which is the first one is called contract, and the second one is called contract with token. So the first one, this is what it looks like. And then what this does is to allow you to send message from one protocol to the other, right? So in this example where we have core contracts, this particular function is used to send message. So you can have like a destination chain where you want the message to go to the contract address, and then the payload. So the payload in this case could be a string, an array, a JSON, whatever that you want to send. And then we have the underscore execute method, which is a method that runs on chain, that runs automatically whenever a message is received in the destination chain. And you can also embed custom functionality of some actions that you want those actions to happen immediately after this function is triggered in the destination chain and executed, and it will be executed successfully. So this is one example for core contract for sending message. Let's look at the second one, which is core contract with token, that allow you to send message and assets. You specify the destination chain, the contract address, the payload, and the symbol, and also the amount that I want to send. You can see this includes like information about assets, symbol, and the amount that I want to send. And then work pretty much the same way, because underscore execute with token automatically executes on the destination chain. So you can have additional information that you want to embed, or a logic that you want to happen whenever this call is triggered on the destination chain. So to give you an overview of what that end-to-end call will look like. So this is an example from Ethereum to Base. And so whenever you trigger an application from a dApp, whenever a dApp triggers a call contract method, a call contract function, it goes directly through the gateway that is deployed for that particular protocol. In this case, for Ethereum, right? And then it emits an event that goes directly to the Axelar network itself, where validation and consensus is being reached, signed, and approved, right? And it goes directly to the gateway for the destination chain, where approved call contract is called to confirm that yes, this particular call has been truly signed and approved from the gateway, and it goes directly to the other receiving end, where underscore execute function gets run automatically, and which is on the destination chain. So this is how you send message from one protocol to the other. Just to keep things simple and direct, in this tutorial, this is what we'll be leveraging to send our message from Base to Optimism. So yeah, this is the demo session where we'll see all of these things in action. But then if you want to see what the final repo looks like, please feel free to scan this QR code. It's going to take you to the project where you see the final version, and then you can just play around with it and deploy it and test things yourself. But then what we'll be doing in the demo is we'll create a new project, we'll install some packages, we'll build frame pages, then we'll build the backend, which is the server I talked about earlier on. we write and deploy the contract. So this contract here is the contract that we want to send message from. So we're sending message from one network, which is Base, to Optimism. So in that case, we deploy the contract on Base and also Optimism. We'll interact with the contract on Base, and then we'll retrieve the message that was sent from Base to Optimism we'll retrieve it on Optimism. Right. So let me share my screen. Let me share my local environment. So we have this. This is a fresh state. I believe you all can see my terminal, but let me zoom in a bit. Yeah. So what we are going to do first, according to the instruction I gave earlier on, is to create a new Next.js project. But I've done that already, right? I've created a new Next.js project. But if you want to do it, you can just go ahead and create it. You can name it anything you want to name it. But then because this is just an example, I won't proceed at the end because I already created it. So let me just call it example and then click next. I want to show you some of the selection I selected so that we are on the same page. I selected TypeScript, I activated ESLint, I also enabled Tailwind CSS for beautification. I did enable the source directory, and then I enabled the app router. For import alias, I said no. So these are the options that I selected in case you want to set up your own project also, so that we can have the same thing at the end of the day. So since I've already created it, so this is what mine looks like. Let me zoom in. I believe you guys can see my screen now. Even better, right? So yeah, I also added few assets here, which I'll just be using. We are talking about frames here. So we want to also give it some beautification on what it should look like. But then before we start coding anything, let's see what the end result looks like, right? So I mentioned Wapcast frame validator earlier on. Let me zoom in so you guys can see clearly. Yeah, I mentioned Wapcast frame validator earlier on when we started, where you can test your application before going live. So this is the final URL here. So let me just clear this. If you reload, if you go to Wapcast / this / developers / frames, you should land here by default. Then now you can paste your final version of the application here, and then click on this button. It's going to load up your application for you, and you can see it also gives you feedback on what is working and what not. Right, so we have all of these things working, and then we can just quickly interact with it. So this is saying what GMs are, and then I can click on it. You can see it's loading directly here, and if you scroll down here, you can see some other things that are also available that you can take a look at. The frame, the post URL. So this is for this page, right? This is if I click on this, where it is going to go to. So this is the first button here. Send message, right? You can see the title is send message, post URL, this is where it's going to, and then the target at the end of the day here. And then we have the second button that's also post, but then that reads, it gets data from Optimism. And because of course we want to send message from Base to Optimism. And at the end of the day, sending message, we want to confirm that the message has been received on Optimism, so we can read that data directly from the frame on Optimism. So this is how you send it, so you can send it. But before I try to send, let me show you the last example I did where I already sent a message. So let me click on read data. You can see everything's happening on chain, and then I get this particular response saying message from Optimism build on chain. Build on chain was the message I sent from Base to Optimism. So while we are trying to build our own, let me quickly do a test. So we can send, let me say hello world, right? So let's send hello world here. And if I click send, you see this pop up here that says I should continue my wallet. This is exactly the experience users are going to see when they click, and then they can just click continue. It will redirect to their MetaMask that they can pay. Okay, I'm on Ethereum minutes, I'm switching to Base, and then I can confirm this particular transaction. So it's pretty cheap because it's Base. So you can see that I have this notification saying transaction what? Sent, right? And I can confirm this status here. So if I click on this, it takes me to a brand new URL where I can see that this transaction was truly sent, just 12 seconds ago, right? So, and then let me come back. So this is the experience the user is going to see on their app. It's just going to show this pop-up without, leaving the application. And then once you click continue, you can see we have a landing page that it results to where we can actually view the transaction on chain or read on Optimism. So if you click on read on Optimism right now, you're still going to see the old message because we just triggered a new message. But then let's view the transaction. This is an external. So when you are leaving the client, it's going to show you that yes, you are leaving the client, and then you can click I understand, and it's going to take you directly to Axelar GMP, Axelar scan website, because this is what we trigger. So we triggered a transaction from base to Optimism. You can see we triggered from base to Optimism. You can see the sender, you can see this, and you can see other information. So the transaction is currently being finalized. So remember, we sent hello world, right? So let's just leave it while it's getting finalized and go back to application to build our own. And then we can come back and then read data from Optimism to be sure that we've received the message on Optimism. All of this is going to happen within the Farcaster application. How cool is that? Right. So let me pause here a bit and check if there's any question. All right, there's no question. So I can proceed. Let's just keep this. And then let me go back to my application. Yeah, so I have this already set up. So what I'm going to do now is to, first, what we want to do is inside our app, you can see this app, we have page, right? We want to, this is the default page, so you might not really need, the default page. But what we want to show here is we want to be able to see, let me go back to the home page here. So this is the default page we are talking about here. We have an image, we have a button showing GMSAR, and then we want to have an action that whenever a user click on this button, it should redirect somewhere. So this is what we are going to code right now. So I'll be deleting some of these because we won't be needing them. Let me just delete these. Yeah, so we won't be needing all of these. Spread things out. Yes, so I can have, because I just want to show that landing page, but at the same time I want a very beautiful view that will just show that yes, the application is up and running. So in that case, I can just return this here, which is saying just the title saying view the Farcaster frame to send message with Axelar GMP. So this is what I want to return by default on the UI. But remember, we are dealing with meta tags here, right? So I need to set up what exactly should show and what are some of the things I need to show for us to create that landing page that we also. So what I can do here is to, I can create a very simple app information that contains my data that I want to preview. So in this app info, I have things like the Farcaster frame, the title, that's the name. I have the description, I have the image property, and I have the post URL. So because I have these assets locally already, so I can change this to localhost for 3,000, right? This is correct. Yeah. Oh, sorry. Yeah. So I can change this to localhost for 3,000, and let me change this too. So I should be able to get that locally. I'll tell you something that you can test locally. And the cool part is even before you deploy, you can also test the application. But the only thing is that if you're testing the transaction, you might need to deploy that application so that you can test properly, because you might not be able to test it locally with some testers. But then there are also some that give you a dummy Farcaster ID. But I always recommend that once you build out your application, you can always use this Webcast, platform to test for free. You can test your application. You can make sure that everything is going fine before you share with the public. So now we have this information. What we are going to do next is to create our metadata, which you can say frame metadata. data. So we need to create our frame metadata. And the cool part is I can do this using, there are different ways to do it, but because I want to define my metadata, we need to install something that can help us, create this this metadata that we want to define here. So one thing I missed previously is to install a package, the on-chain kit package. So let's go to their documentation here. We go to on-chain kit / on-chain kit.xyz. Let me zoom in so you can see my sync query. So you can see that this is a kit that you can use to build your frame. So what we just need to do is come here and then copy this and go back to our application to install that. To install this particular package that will allow us to create that frame metadata. Of course, you can create it with the metadata example that I showed during the application, but I want to use this framework because it helps us make things cleaner and also help us build faster. So let's just wait for it to install. So while this is installing, I can go back to I can go to my application and then import it directly. So once it's done installing, we are just going to continue coding. So now I've installed the get frame metadata from this. This is still installing. That's how you can see. That's why you're seeing this here. So one thing I want to do next is, since I already defined this, I can tell what do I want to have. What do I want to have on my front end? Like in the example that we have, we need a button. This is meant to be on my page. We need a button, and then we need to assign a label to the button, right? Like what is the name of the label? So I can call this GM so that we can tell the difference, right? The first one was GM star, and then here I want to call it GM. So now we have these, and then we can proceed to enter like the image URL, the image that we need here. So as you can see here, we can just click this and then we use the image that we created earlier on. And also we need a post URL. We need something that whenever this button is clicked, where should it go? Or like, what is the action behind that button click? So you can save this now. And then next, what we want to do is to now add the export the metadata by default. So I can say export const metadata, and then we import from we would use this metadata type that we imported from Next.js. Data equals to so here we have, let me scroll up so that you guys can see. So here, there are a few things we need to define. We need to define the title, which is the app info, the name. We need to define the description, and then we need to define, remember our open graph, right? Open graph. Then inside the open graph, we'll have things like the title, the image, the images, and then the images could have a particular length. So let me just make this 630. And then we have other information and the alt for that particular image. And after creating it this way, what we want to do next is to say other parameters should include the frame metadata that we created before. Yes, so what's going on here? It's not assignable. It should be, okay, inside the open graph, let me be sure we are outside. Let me try to confirm. Looks like we are missing something here. Because then we have these and that. Not exactly sure what we are missing. So we have the name, we have the description, images, URL, info, app.info.name. It should be good. Oh, okay. I think it's because of this. Let me see. Is it this? Yeah, this should go now. Try to miss a step here, but let's quickly fix that. And just proceed with this. See maybe missed typo here. Yeah, I think this is not an error attributed to where I'm looking at them. Oh, yeah, I think I found the error. So what happens is that we just created a JSON. We didn't use this guy here that we want to use it to create a frame metadata. So what we are supposed to do is to do this, open this, and then close this. So that way we fix the error, right? So we use the get frame metadata to create the frame metadata and then assign it to the general metadata for the part for our application. So now we've done the simple home page. So what we can do is to start our server. Yeah, this is done installing. Let me just clear. So I can do npm run dev, and this should open something up at localhost 300 for me. So if we go to localhost 300, we are going to see this. But then the interesting thing is that we cannot, this is what we are going to see to show that our application is working. But then we need to validate that it's truly working before we go and test here. We cannot test localhost here unless you create an ingrok server that can create a tunnel so that you can have HTTPS to test here. But then there's something called frames.js, or like in this same on-chain kit, they have a frame here. So that frame here, let me show you what it looks like. So this frame here allow you to preview locally. So if you clone this project, go to the frame directory, do npm install and npm run there, you see this. So I have this up and running already. So I can just paste in my URL here, local host here, right? And then we'll specify 30,000. Is this correct? Yeah. So then I can click fetch. Local host for 30,000. Yeah, that's correct. I think we are missing something. Yeah, so API of the public. Let me go back and see. Be sure we still have our application running. Then we can click on thing here. Oh yeah. So I think I didn't enter what I was supposed to enter correctly. So right now we have all of these check mark. The only thing that is not showing here is the image. So let's fix that quickly. The image here, let's see what image URL. Looks like, did I spell? Oh, okay. I think I added S here because it's localhost, not S. So we go back here and then click on fetch. We can see we have our URL. So we have our landing page with the button that says GM, right? And then you can also find other details here, right? So this frame, this particular button has a frame post URL called home, right? And we don't have that home yet. So what we are going to do real quick is to go back to our app, create a new folder called API. And then inside that API, we'll create a new folder called home. And in the home, because we want to create a route, we create a new file called routes.js. So whenever anybody click on that GM, we want it to come here from the beginning. So gm.ts, right? Sorry, route.ts. Why did I say gm.ts? So now we have the route here because whenever a user clicks, we want it to redirect to this page. So that page can include some of the action that we want to happen. So to make things fast, because you have like a ton of things to cover here, so I'll just put this in so we can see what exactly we want to change there. So on the UI, if you remember our application, whenever a user, let's go back to the webcast, whenever a user click on GMSA, it takes them to a new page that has input and then two buttons. So that's what we want to do here. First one is input. We can see we have this method called the get frame HTML that can return HTML to the user. So this is what we are using here to create our input and also specify the buttons that we want to have, right? So we have these buttons here. We have this button that says send message. We have the other one that says read post. And then the both buttons have like different targets and also post URL. And at the end of the day, what we want to have is whenever a user click on send message, it takes them to, it goes to the target to call send message, and then have at the end of the day, when the message is sent, it goes back because this is a fallback URL. Whenever everything goes through, it goes back to the send message success and then return a UI. So now we've tested this particular part. Let me go to our local environment. This part where we have a very simple page here, right? So let's implement this so that we can get redirected to this particular homepage. So I have these, I've saved these. Let's test again. Let's fetch and then click on GM. So now you can see GM returns this page for me where we have two buttons. We have send message and then read data on optimism, right? You can see everything check mark. The cool part is that because I'm doing this locally right now, you can see if anything is faulty here. Remember, I'm not using localhost here, but because I have an application already with this image, so it still works fine, right? But in your own case, if you, of course, you have not deployed this before, and you need to use localhost here instead of using GMP here. You need to just once you specify localhost and you have this, it is going to work as expected. And at the same time, for images here, you have the same thing. So this particular one, we need to do it in such a way that it to redirect to our local. Yeah. So images would work fine. Images would work fine, but let's fix this button because this is going to try to redirect to a domain that is different from our local. And because we are testing locally, we don't want it to be like that. So I can just change this real quick to I just find and then this, and then we can replace with HTTP localhost. Yeah, and then specify the port 3000. So let me just do this one after the other to be sure we are replacing the correct thing. Right, so everything should still work because now I'm just pointing it back to our local development. So now let me go back and fetch again. Everything should still work as expected. Right, the only thing we just change like the action points so that it points to our local environment and also the images, right? And because we have the images locally, it works as expected. But now what we need to do next is to send message, to be able to send message and later read message. But because this send message requires an on-chain transaction, because now I want to send message, I want the user to sign and then execute that particular transaction. We won't be testing this locally, but then I just wanted to showcase that what you can do locally, you can also test your frame, locally. Moving on to the next step now, where we do the send message, we'll just write the code, write end-to-end code, and then we'll deploy this application to Vercel to test if it's still working as expected. That's what you've seen in the beginning of this demo. So now, but then we want to send message from where? From Axelar and from base to optimism using Axelar GMP. The first thing we need to do first is to write a smart contract. Axelar Smart. So you can go to Remix or you can do it locally. You can write your smart contract there. So first thing we want to do is to import Axelar executable from the Axelar GMP, the gateway, and the gas service. So you might wonder why gas service? What exactly is this gas service? So the first one, the gateway, this executable exposes like functions to us that we can use. And also the gateway exposes the core contracts method that we need. And the Axelar gas service here that are importing from the Axelar GMP SDK would allow to help us pay gas for this particular transaction call. Ideally, we are supposed to pay gas 3 times, pay on Wave, to pay on AXL, because Axelar network is a decentralized network itself, and then we pay on optimism. But then with this gas service, you can just pay once, and then it should be used for the end-to-end execution of this transaction. So what we want to do here is to create a simple contract called send message. I'll be faster with it here. And then it extends from what? It's Axelar executable, and this is the contract I want to create. Right. The name of this contract is called send message, and it's extending Axelar executable. I need to define a view variable that would, allow us to save the value, that's the message that we want to send, the source chain where it's coming from, the source address, and also the gas service we create like a variable for it. And for every contract that you want to deploy on every chain, right? If you are extending the Axelar executable, you need to specify which gateway and then which gas service that you want to use. So we'll create a constructor here that will allow us to do that. So for example, if you are deploying on Polygon and Avalanche, or that Ethereum and Base, right? You need to specify the gas service on Ethereum and the gas service on Base. So this is what we are doing here in the constructor. So before you deploy, you have to do that, right? And then once you deploy, so once you set this constructor, when you want to deploy, you can specify these both addresses, which is the gateway and then the gas receiver. Now, moving on to the action point where we get to the function I will create to call, to send our message, right? So we are going to create a new function called set remote value. And what this is going to do for us is to allow to trigger that message by calling core contract function that is available to us using the Axelar gateway. So you can see what we are doing here. We're specifying the chain, the destination address, and the value, which is the message that we want to send. We're making sure that users pay gas for the end-to-end execution to go through without errors. And then we are encoding the payload, which is the message that user is trying to send. And then we are calling the gas service to pay for this particular call. We pass in a few parameters with the address, which is contract, destination chain, destination address, payload, and message of sender. I want to talk about this message of sender because sometimes if you pay a transaction, you can pay excess, right? If you just randomly enter a particular value, it might not be enough, or you pay excess. So whenever the system runs end to end and there are leftovers, like remaining gas, you'll be refunded to any address. That particular gas will be refunded to any address specified here. But in this example, we are specifying the message of sender, which is the person that initiated this call. And then we are now calling the core contract from the Axelar gateway to initiate this message sending, right? So now, the one last thing that we need to add here is the execute method. This execute method would allow us to, okay, yeah. So this is the execute method I talked about during the presentation that you can add to and specify source chain, source address, and the payload. So what this is doing is to decode the payload that was received on the destination chain. And here we are assigning to a value because we want to be able to read that payload on the destination chain inside our Farcaster frame. And then we are also setting the source and the source address. This is another form of verification to ensure that the call was actually initiated from the origin, which is the first network for sending it from to the second one, right? And this is all we need to deploy our application. This application will be compiled. We can just compile, and then we can, if we want to deploy this, what we are just going to do is, you see this constructor here, we need to pass in the gateway and the gas receiver. So how do you know the gateway and the gas receiver? You can go to docs.axelar.dev. If you go to docs.axelar.dev, you land on this page. Just click on developer, and then on the left-hand side, scroll down a little bit, see contract addresses, click on testnet. If you want for mainnet, you can click mainnet. If you want for testnet, you can click testnet. So another thing I didn't mention is because now we want to test on like on using Webcast, right? We don't want to do it locally, right? We want to do it on mainnet, of course. In this example, we are just going to copy, you can see the base gateway contract and then the DAS service. These are the two values that we need here. And we can paste this here, go back to the docs, scroll down for optimism because that's what we are using in this example. Sorry, I think we need to copy the second one before we go to optimism. So this is for base because that's the first place we want to deploy our contract to. Right. And you can see that I copy the address from mainnet because this is going to be on mainnet. So this is exactly the approach or the step that you need to deploy your application. So for my own case, I've already deployed mine and I have my contract addresses. So what I'm just going to do here is to paste in the contract address here for base and just paste it here. And then for optimism. But if you want to do on your own, if you want to deploy this application, just specify the parameters I talked about, and then you should be good to go to deploy this particular contract. And then you should have the base address, the contract address, the hash, the address that was deployed, and then also for optimism. So now we have these two. What we need to do is go back to our application. Once we are back to our application, we can, under this folder, under the app directory, right? We can just create a new folder called underscore contract, right? You can feel free to name it anything, but it's always good when you name it something that is very easy to understand. So, and then what we want to do here is to get the ABI so that we can be able to interact with the contract that we just deployed. So I'm just going to create something called because the contract will deploy send message, you'll do the call send message ABI.ts, right? And click enter. So what we need here is the ABI. So there we can just go back to our contract to get the ABI. So let me go back. If you go back to Remix, you can see if you click here, scroll up where we deployed, scroll down a little bit, you can see this icon here saying ABI. And copy this, just click on it, it's going to copy it, and then come back here and paste it in. So now we have our ABI, but let me just define this that you call this cons. All right, we have our ABI. We are good to go to interact with our contract. So now we need a UI to interact with this contract. We have our home already. We need, what we need next is whenever a user click on send message, it should target this to execute sending that message. And whenever that message is successful, to fall back to this other route, right? So first thing first, what we want to create is send message. You can go to make sure you are under the API, create a new folder called send message. You can create another folder. Let's just create all the folders that we need. Send message success. I just call it, feel free to name this anything that you want to name it. And then finally, because after sending the message, we want to be able to read the message, you can just define another one message, right? This is also another folder. So inside send message is the first one. You can create something inside. You can create a route.ts, right? And then let me close this so that we have a fresh slate. And inside this send message, what we want to do is whenever you initiate that send message call, we want to be able to send message from base to optimism because that's where we deployed our contract. So to make things faster, let's add this here. So we are importing a few things. Yeah, the first thing we have is the on-chain kit, and then the ABI that we are importing. I'm not sure why this is showing this error. Let me confirm what happened. contract, send message. So contracts, then send message. Yes, should be. You're not supposed to have. I think this is part of the module. I'm not sure why it's showing this error. But then let me see if we can quickly fix it. Yeah, send message that ABI TS. This should be it. Let's go back to the route. See what. So this is what I have. Okay, what I was able to do to fix that was inside this. I think when I declared this particular input here, so this is the ABI. You need to export it, right? So that was what I didn't do. That's why we're having that error. So now that we've export the default ABI, we see that the error is now fixed. So what we need to do next is to get the base contract address and then the optimism contract address, which is what we have here. All right. So if you deploy your contract, that's what you are going to have. And then now we are going to create a function called getResponse, which we are going to check the frame, like use the frame request type that we got from the on-chain kit, get the body of the request that comes in, validate this body, that yes, this is a valid response. There are things that you can also use to do because validating this way, you are using the untrusted data. I don't want to go into like much more details there, but it's very good to mention that if you want to validate that yes, truly you have a valid data, there's also a service that you can use called Nina that you can use to validate. In this case, we just want to keep things simple here, and then we have this. It returns this if it's not a valid message. And then what we are doing here is to encode the function data, which is another one that we got from VM here. So see what we are doing. We're specifying the send message ABI, and then we are calling the set remote value, which is the name of the function on our contracts. Let me close this for a second. You can see this is the name of the function on our contract, and then we're specifying the arguments, takes in destination chain, destination address, and the value, which is what we are specifying here. Specifying our destination chain is optimism. Our destination address is this optimism contract address that we want to interact with. And our message is the input text that we got from our UI. Remember that the UI here, if you go to our frame J, you can see the UI has input box. So whenever you click, we are grabbing that inside the body, we are grabbing the input text, that any text that was entered here, and then we are using that because that's what we want to send, right? And then we are creating a transaction frame response, specifying base ID because this is going to trigger from base. We are calling this method to send transaction, and then we specify the data that we encoded here to, because this is going to be initiated from base, right? Specifying base here, and we are specifying a very small amount of gas. And the cool part is I wanted to show this so that you can see, but we also have another way for you to estimate what string call why you don't have to add code here. It's called the Axelar GS SDK that you can use. But I want to showcase what you can also do on the Axelar scan in case your transaction gets stuck for some reason. So let's see if this will be enough for this transaction to go through. If not, we're able to top it up directly from the Axelar scan UI and then to make the transaction go successfully. Finally, we export this post method, tell that we want to make this post, and then also making it dynamic. This is what we need for us to trigger a message from one network to the other. This example from base to optimism, right? So now that we have this, remember that the first one in the home route that we have, that we showed previously, the target was what? To call this send message. But then we need a post bar. So whenever the action goes successful, what page do you want the user to see? You don't, of course, you don't want them to see like just a blank page or error page. You want the page to land somewhere after it's successful, which is why we created this send message success route. So inside send message success route, we just need to do something very small here. Let me open that route. Okay, I haven't created. So inside the send message dash just send message dash success folder, just create a route dot ts, and then inside this route dot ts, we can quickly add the code or what exactly we want to do here. So the original app, whenever a transaction is done successfully, it goes back to this page where you can either view that transaction or read message from Optimism. Don't forget. But then in this case, what we want to do is to do the same thing so that we can either show to view transaction on Axelar stamp or you view on Optimism. So click and I pasted this here because we are pretty much doing the same thing, getting all of this importation, our function that we need, validating the body and making sure that it's valid. And then we are returning a frame response here, which is two buttons to view transaction. We encoded this because we can get transaction ID whenever we send a transaction request. So you can see that the object is untrusted data, like I mentioned earlier on. And then we can track the transaction ID there. And also, we have another button that says read data on Optimism, where we can also read that particular data. So I know we are still going to change this at the end of the day, but let me just change it right now because we are going to deploy this app. So we'll change this to the base domain of whatever URL it is that Vercel gives us. Right. So localhost 3000. Yeah. So I can just copy this and then just make sure that we have the same thing. Right. So this, all of these things are in localhost. If you click here, we want it to open Axelar scan on mainnet to view our transaction. Now I can go back to, so now we set the success. So whenever successfully lands on this page, right? One last thing that we need to do here before we test our application is the read message. So we want to be able to read message. Now the message has been sent successfully, but how sure are we the message went through? Let's create a new file here called route.ts under the read message folder. We want to be able to read message on chain directly from our frame. It's very easy because you can just call that particular value that we save on chain. Remember, in our contracts here, whenever execution is complete, right, we are decoding that particular payload and assigning it to a value, which is this value here, a state variable that we can read publicly. So that's what we want to do. We want to read the value on chain to make sure that yes, truly we have received this message on the destination chain, which is Optimism. So do something similar, importing like all of the variables that we need, bringing in our Optimism contract address here. What we are going to do here, which is a public client that we need to create, still from our VM that we install when we're installing the on-chain kit. So we can specify the chain, create the transport here, and then get contracts. We're also calling get contracts from this, which is another function that we imported. We're specifying the contract address, the ABI, and then the public client. Now we are awaiting this particular request. And then once we have it, we save it to value here, and then we display it. That is why we are having this here. So you can see this is showing message from Optimism because we are reading from Optimism. So we need to display the message. And then let me change this again. We'll still come back and change everything when we have a URL because we want to test this transaction. And because it's on mainnet, we need to test properly in production. So using the Farcaster validator tool that we have, you don't have to tell the word yet. After testing everything, you can now paste it for everyone to test out. So now let me just look host 3000. So I have this now. I have everything set up. This is actually an image that would show on that UI. So you might be seeing this like often because you're specifying on this page. This is what I want to have on this page. This is what I want to have. So in this case here, I want to have this image showing. Now, I think we are done. So we are done. Now, what we just need to do is we've implemented all of the feature that we need. interacted with our contract. So we need to test this application. But because we are interacting, we're sending user transaction. We've tested the UI already here, so we can send. But for us to test the same message, we need to have our Farcaster account connected so that we can test in real time. So let me just quickly deploy. If you're using Vercel CLI, it's easy. But then let me do a Git initialization here. I'll stop it now. I think I can go the other way around. Let's just quickly deploy this application. So what I want to do is to just create a new GitHub repository. Feel free to name this anything. I make this private, then this is just test. We already have one that you can share and take a look at. So now I can now just go back to my my terminal and then just add this, and then I can do git. Sorry, let me confirm that. Yeah, okay, yeah, I can set the branch and main, right? So I can get that wrongly. Let me confirm real quick. Yeah, this is correct. All right. So just do this. Oops. Where can do this. Yeah, this is going to push and be sure that we have everything set. Yes, so we need to commit this files. Yes, I can do git push now. So now I've pushed it, so I can go directly to my account. Let's just refresh this page to be sure we have it. Yeah, we have this pushed already. So I can go to my dashboard on Vercel. I can just quickly select that particular project that we just push so that we can test it at the end of the day. Yeah, let me click on add new project. So this is the same process also if we are using Vercel, right? So we don't have any environment variable, so we can just click deploy. Then once we click deploy, let's just wait for it to deploy. But I can already guess that this application will be Axelar frame-gmp.vercel.app. But then let's just wait for it to confirm. We're running out of time already. So then we are almost done. So while I'm waiting for this to deploy, let me see if I have any question. Okay, looks like there's no question. We're good to go. We just have one more step to finish this entire session. Yes. So this is still deploying. So while that is deploying, let me see if I can just use HTTPS because we need to do one more push. That's Vercel. I think it's Vercel.app, right? So we are good. It's usually faster. I don't know what's going on. Okay, yeah. So now we have our app deploy. You can see this is what we added on the home page. So we have this, so we can just continue to dashboard, and then we should see this, which is Vercel.app. So one last thing, remember that we're testing locally, but now we want to test production. So one last thing we need to do is http/local hosts 3,000, right? So not studio, sorry. So now we have this. What we just want to do is to change. Yes, so maybe we don't need this, we don't need the readme, but we need to change it in the page here. We need to change it on our buttons and also our images. We need to change it here, here, and here. So now that we've changed it everywhere, I think we are good. We can just do a push and say update URL. I intentionally want to show you guys like what the process looks like. So in case you're doing it yourself, you can either set like an environment variable and change the key. But if you want to like go the way of pushing it here. So when you set an environment variable, you can only just change the environment variable and then come back to Vercel, set that same environment variable, and you should be good to go. So it's either it's local or production. But then if you want to test transaction, just recommended to do its production so that you can use the Farcaster frame validator, this one, to test the application. So this is the previous one. Let me duplicate this and then go back to Vercel. Make sure this is deployed successfully. So let me grab the URL. So let me grab the URL and go back. So this is also ready on Vercel, so we can test on our clients. Let's paste this here and then click this. You should be able to see the same thing. You can see we now have GM, which is what we just implemented. And then once we click on GM, you can see everything works as expected. And then we can send this is the new app. So we can send a new message called new application. Okay, let me say, well, admin. Yeah, so you can click on this and it's going to bring this pop-up. Yeah, you can continue to sign our transaction in the wallet. This is the new one we just built out together. So pretty exciting to see everything works as expected. You can click continue. You can see we landed on this page, which is the success page. You can click view transaction, takes you out, and then you view it. But then, so this is going to showcase, and then let's wait. So now it's going to, you can see show sent, gas paid, and it's waiting for finality. So let's go back. Remember in the beginning of this session, when we were testing this application, we sent hello world, right? And then we went ahead to build our own version. So now let me just click on read. We are supposed to have a response now. You can see we have what? Message from Optimism, hello world. Woo! That's pretty exciting, right? So we're able to send this from base to Optimism all within the Farcaster frame application. But one thing you should know that is I'm just using base and Optimism, right? You can decide to make it custom in such a way that the user can select which network directly from the frame. And then once you select it, you grab that selection, and then you'll be able to deploy, you'll be able to like interact with the contract that was already deployed on that network that you give the user to select from. So you can make it dynamic. In this case, I'm just choosing base and Optimism, and then I'm specifying it directly. But if you want it to specify by the user, you can do all sorts of things. In fact, you can, this is like really basic example that you can deal with frames. There are a lot of custom functionality that you can add on your own to make things even really cool than what we currently have. So, but then this works fine as expected. Thank you all. So let's go back to our presentation and then round things up. Yeah, so we're able to do all of these things successfully as intended. If you want to get like the code sample, please just scan this QR code. It's going to take you directly to the final code, and you can see, you can update things. Feel free to ping me anytime on Twitter or LinkedIn. I will be happy to help with any questions and also build even more sophisticated Farcaster frames. Yes, so one last thing to mention is we have a repository in case this is the first time you're in Axelar. you have not implemented Axelar before, you've never interacted with it, please welcome, check out our documentation. We also created this example repo that contains a lot of examples that you can try out on your own. Please feel free to give us feedback too. We're happy to receive feedback. And at the same time, you have this example that you can run locally and test things out. In fact, you don't need faucets, or you can just do all of these custom tests locally, and you should be good to go. And then finally, this is another QR code that I employ everybody watching right now. So please scan, give me feedback, what you think about this workshop, how you find this workshop helpful, and also how you recommend this workshop to a friend. It takes less than 1 minute to fill in this short survey. I'm really excited to hear feedback from you guys. Thank you all for joining. But before we call it a day, let me see if we have any question that I can answer. But if not, we can call it a day. It says, do you think so yeah, there's one question here I want to show here. This person says, do you think the code will be much different from if the end chain is Cosmos? It's not going to be different. The cool part is that we have like Cosmos GMP examples too that you can send from. So you can feel free to check our documentation. It's pretty much similar step that you are going to trigger from one protocol to the other. And this person also is in Spanish. Sorry, I don't speak Spanish. I hope I can answer your question, but you can send me a DM on Twitter. I'll be happy to answer all of your questions. Thank you all for joining. I don't want to take you guys' time much more than this. I really appreciate it. Thank you all for joining once again. Bye for now.